Welcome to Geomechanics 1. We learned about igneous rocks in the previous video. In this short video, you will learn further details of sedimentary rocks. I would like to start this video introducing the rock cycle and the origin of the soil. The mineral grains that form the soil are the product of rock weathering. Many of the physical properties of soil are dictated by the size, shape, and chemical composition of the grains. To better understand these factors, we must be familiar with the basic type of rock that form the earth crust, the rock-forming minerals, and weathering processes. As we already discussed, on the basis of their mode of origin, rocks can be divided into three basic rock types: igneous, sedimentary, and a metamorphic. Here you can see a diagram of the formation cycle of different types of rocks and the processes associated with them. This is called the rock cycle. The rock cycle is a basic concept in geology that describes transition through geological time among the three main rock types: sedimentary, metamorphic, and igneous. The rock cycle explains how three rock types are related to each other and how processes change from one type to another over time. When rocks are pushed deep under the Earth's surface, they may melt into magma. When magma cools and solidifies, that forms igneous rocks. As we discussed in the previous clip, when a rock cools within the earth is called the intrusive igneous rock that cools very slowly, producing a coarse-grained texture such as granite. As a result of volcanic activity, magma may cool very rapidly while being on the Earth's surface exposed to the atmosphere. Those are called extrusive or volcanic rock, such as basalt. Rocks exposed to high temperatures and high pressures can be changed physically or chemically to form a different rock called metamorphic. We will learn further details of metamorphic rocks in the next video. Weathering and erosion breaks the original rock down into small fragments and carry away dissolved materials. These fragmented materials accumulates buried by additional material and cemented, resulting in sedimentary rocks. We will discuss details of weathering process and the formation of sedimentary rocks in this video. Weathering is the process of breaking down rocks by mechanical and chemical processes into small pieces. Mechanical weathering may be caused by the expansion and contraction of rocks from the continuous gain and loss of heat, which results in ultimate disintegration. Frequently, water seeps into the pores and existing cracks in rocks. As the temperature drops, the water freezes and expands. The pressure exerted by ice because of volume expansion is strong enough to break down even large rocks. Other physical agents that help disintegrate rocks are glacier ice, wind, running water of streams and rivers, and ocean waves. It is important to realize that in mechanical weathering, large rocks are broken down into smaller pieces without any change in the chemical composition. In chemical weathering, original rock minerals are transformed into new minerals by chemical reaction. For example, water and carbon dioxide from the atmosphere form carbonic acid, which reacts with the existing rock minerals to form new minerals and soluble salts. Soluble salts present in the groundwater and organic acids formed from decayed organic matter also cause chemical weathering. Quartz is highly resistant to weathering and only slightly soluble in water. As we discussed in the previous clip, the minerals formed at high temperatures in bounce reaction series are less resistant to weathering than those formed at low temperatures. Rate of weathering governed primarily by climate, mainly temperature and moisture, and rock types. One of the key points I want to highlight here is that all types of rocks can be weathered into sediments. Here you can see several examples of mechanical erosions due to ocean waves. The harsh and extreme weather conditions from the Southern Ocean gradually eroded the soft limestone to form caves in the cliffs, which then became arches that eventually collapsed, leaving the rock stacks as we can see today. Sedimentary rocks are formed by mainly three ways. 1. Sediments that transform to rocks through lithification, commonly compaction and cementation. 2. Direct or indirect precipitation from seawater. And 3. Organic origin. The deposits of gravel, sand, silt and clay formed by weathering may become compacted by overburden pressure and cemented by agents like iron oxide, calcite, dolomite, and quartz. Cementing agents have generally carried in solutions by groundwater. They fill the spaces between the particles and form sedimentary rocks. Rocks formed in this way are called detrital sedimentary rocks. All detrital rocks have a clastic texture. In other words, the rocks are composed of fragments or clasts. Conglomerate, sandstone, siltstone, mudstone are some examples of detrital sedimentary rocks. Therefore, considering the origin of sedimentary rocks, we can divide them into two groups: detrital or clastic sedimentary rocks, chemical and organic or non-clastic sedimentary rocks. As I previously mentioned, detrital or clastic rocks are made from sediments that are transported as solid particles. Sedimentary rocks also can be formed by chemical processes. Rocks of this type are classified as chemical sedimentary rocks. Limestone, dolomite, and gypsum are some examples of these types of rocks. Sediments are directly precipitated from solution in seawater or indirectly by the aid of organisms like corals forming these rocks. Organic sedimentary rocks form from the accumulation and lithification of organic debris such as leaves, roots, and other plants or animal material. Coal is a good example for an organic sedimentary rock. The most common way of characterizing sedimentary rocks are layering and fossil content. Layers or bedding planes and the presence of fossils are a good indication that the rock is sedimentary rock. However, we need more accurate scientific methods to identify sedimentary rocks. Texture or the particle size distribution provides the scientific basis of classifying detrital or clastic sedimentary rocks. Conglomerate is an immature sedimentary rock that is poorly sorted mixture of clay, sand, and rounded pebbles. The mineralogy of the sand and pebbles can vary depending on its source. In the case of conglomerates, if the particles are more angular, the rock is called breccia. In sandstone, the particle size may vary between 1/16 mm and 2 mm. When the grains in sandstone are practically all quartz, the rock is referred to as orthoquartzite. In mudstone and shale, the size of the particle is generally less than millimeters. Mudstone has a blocky aspect, whereas in the case of shale, the rock is split into flatty slabs. We will discuss further details of these rock types during your first lab class, the rock garden. You will learn further details of the particle size distribution of soils in the coming lectures. Here you can see some more review questions that you can practice. I hope you can answer all these questions. That is the end of this section. We will continue geological process, metamorphic rocks, and application in the coming video clips.